All right, one, it's November 25th. All right, let's do this. Largest sub matrix with rearrangements. You're given a m by n. How big is it? Dear me, 10 to the 5th. All right. M by n. But you can do OMN. So the complexity is OMN-ish. You're allowed to rearrange columns of the matrix in any order. Columns of the matrix in any order. Return the area of the largest submatrix within matrix where every element of the submatrix is 1 after reordering the columns optimally. So in this case, I change the column, I got 4. In this case, I can change the column, I got 3. Nice. M not necessarily equal to n. Okay. No clue. By just looking at this. Let's just, do a few. Draw it out. Try to see if we can find any inspiration. So we can move these around, okay? And a submatrix is an area A times B, right? Where everyone is the same. A times B. So we are gonna rearrange. How do we rearrange? It can be rearranged any way you want, right? Any way you want. So, and it doesn't matter where this, like we can rearrange these two, right? We can rearrange these two, will work as well. So it doesn't really matter where this submatrix is. So what are you saying? I'm saying to move everybody to the front. Because eventually we'll find a submatrix, and rows we cannot change, okay? So eventually we'll find a submatrix, okay, that has the maximum, right? That has the maximum. And that means for this submatrix, maybe we can, I don't know, count the number of ones. That might not be a bad idea. We count the number of ones. Because no matter what, it's gonna be the number of ones, right? So we can count the number of ones, and then what? If we count the number of ones, so we have, multiple values. Yeah, it doesn't really matter that much, because you can always rearrange them. So some of them get grouped together, and some row might not have it. All right, so a direct way, it's not really okay at the moment. So what do you think? I'm starting to think maybe we can do binary search. Like we can say the maximum submatrix is a certain value, and then we try to see if we can rearrange it to make it so. How? Well, the columns, so the rows can, the column can rearrange, but within each column, it has to be, right? So this has to exist. This has to exist. So we can go through column by column, right? And find out. Like if, we go column by column. the consecutive. So this consecutive is 2, this consecutive is 1, and this consecutive is 3. All right, so we know in this case, this is not possible. 3 is not possible. But you can say 2 can be possible, but 3 cannot be possible because we want to have one of them is 3. But that doesn't solve the problem for us, does it? It does not. Maybe it's an overlap problem, right? If you think about this is 0, this is a 2 to 3, all right? This is a 1 to 1. This is a 0 to 3. And what we are asking is, what's the maximum thing that we overlap? Overlap. That is an interesting way to see this, right? So we got this. We have 0, right? 1, 2, 3. So we have 2 to 3. We have 1 to 1. And we have 0 to 3, right? So the maximum overlap is this. So what do you say? I sort them, so we go 0 to 3 first. Okay, so we have 0 to 3. And now 1 to 1. Okay. 1 to 1. So we have overlap on 1. So we know how much. Right? And the next. So if they start from 0. Like a 2 to 3, right? So we can do the scanning. So 0, we say +1. Right, next 1 comes in, so 1 plus 1 plus 1, so to 1 plus 1, so it'll be 2. Right? And but if you have multiple starting at 1, yeah, you multiple, so we spread it out with 0. Will be like a 0, 0. That means so 0 is the left, 1 is the right. So 0, 0 come in, and then there'll be 1, 0. So it'll be like this, right? 0, 0, 1, 0, 2, 0. No, 1, 1, 2, 0, 3, 1, and 3, 1. So come 0, 0, 1, 0, and 1, 1. So when we hit a 1, we're going to end it. So what we need to know is, so far, what is the biggest start? Because that is going to determine the current range. So biggest start is 1. So now we have 2 range starts at 1. So the answer is 2 at the moment. But then the 1, so this has to be 1. Right? 2, so now we have 2. Biggest is 2. Now we got 3 is 1, so we need to reduce. So current now is 2 times 2 is 4. And it will be 1. And we do it again. The biggest is 3. Hold on. Yeah, 2 to 3, because it's the range between these. This is 3 to 3, so it's 1. So it's only 1. So the answer is 4. Interesting. Okay, in this case, so we consider it's column, right? So if it's column, this is basically 0, 1 that doesn't have. That is a 0, 1. Oh, 0, 0, my bad. 0, 0, 0, 0. And then 0, 1, 0, 1, 0, 1. Right? So we hit 1, 2, 3, hit 3. Hit 1, so the answer is 3. Alright, let's check the last one. If the last one works, I think this is the solution. So I have 1, 1, 0 and a 1, 0, 1. Okay, so the range, the first range is 0 to 1. Yeah, it doesn't really matter, so we just put it in. Right, this range is 0, 0. This range is 1. 1 to 1. Okay. And when you expand this, so it'll be 0, 0. Right. 0, 0. And then 0, 1. And then 1, 1. And then 1, 1. It'll expand. So every time we should put this in. So it'll be 1, 2. So we have 2. Right? So this is n, so back to 1. And then this, we're back to 0. Yeah, 1, 2. Try by 2, 0, so we got 2. And now we hit this. So we have the answer, current answer is 2. And then we have a 1, so we don't have 1. Right? I think this is 1, 0. Forgot a 1, 0. And our hit is 2 again. Hit this 2, and then back down we have 1. Wait, hold on. 1, we hit it, so we have a 2. And then at the end, oh, it should be another 0, 1. Should be another 1, 1, my bad. Should be another 1, 1. 1, 2, 3, 4, 5, 6. Yeah, I think this one will work. Okay, let's do this. All right, so how are we gonna do this? We are going to do it like how we usually do it. So we need a list of int. Okay, we call it positions. Array list. Okay, and then for each one we're gonna go row column by column. Okay, column. So for j equal to 0, j smaller than matrix dot. I don't think that's the right way. Let me see. We can do a. Oh, the hell did you do? Int m is matrix dot length. Int n is matrix 0 dot length. Okay. So beside this, we don't need this. We're gonna do n. Right, j plus plus. For int I equal to 0, I smaller than mi plus plus. Okay. All right, so each one we go I top to bottom. Now what we need to do is find the consecutive ones. Okay, consecutive ones. So previous. So the first one is a 1, and we need a counter, right? We need a counter. Okay, so we need a counter, which means we need a counter equals 0. Wait, do we need a counter? No, we don't need a counter. That's just what we need is a pre-I. Okay, maybe pre-I, pre-index. Okay, so we say if or maybe if matrix ij, right? If matrix I j is equal to 1, all right? Matrix ij is equal to 1. If I is equal to 0, or matrix I minus 1 j is equal to 0. Right? In this case, if I is 0, which is the top, or I minus 1, this is the previous one 0. So it's a new start. So pre-index will equal to I. Done. Okay. And else, which means I is not equal to 0, and the previous one is not 0. We just keep going. We don't do anything. Yeah. Huh. I think we don't do anything. Else is here. Else. If it's equal to 0. Okay? If the current is equal to 0. If I is larger than 0, because if I is 0, we don't care. If I is larger than 0 and matrix I minus 1 j is equal to 0. Yeah, I kind of don't like the JJ because the J is so slow. I have to go up. Yeah, I think I want to change it. I don't like JJ anymore simply because just like it slows down the J. I think I'll use it a little bit more. Okay, so if I larger than, and then previous one is it's not correct. Previous one is a 1, right? So the previous one is a 1, and the current one is a 0. That is when I need to push into the position. So position dot add new int. So we need to add 2 things. Ooh, I don't need this. I should be position dot add new int I 0. This is the starting point. Start of a new stretch of ones. Right, and then here is going to be I 1. No, that's not right. I minus 1. And of the current stretch once. Right? So when it's a 1 and I is equal to 0, that's a start. Or I minus 1, the previous one is 0, that's a start. So we put a start, right? And if the current one is a 0, right? The current one is a 0. And I is larger than 0 because the current one is 0. If the previous, if I is equal to, I is larger than 0 and the previous one is a 1, that's the end. So we set an end, right? We set an end. So in that case, I do believe we can make them simpler. So let's do this. Let's go up, delete that, come down here, delete that. So we'll do this and this. Right? We need another, so we go here, we do another one, delete this, and then, okay, delete this, and we can do else if matrix I j. Now see, this is so slow. It's equal to 0, and so we're gonna go vi this yank delete, go to this. No, I'm gonna just paste it. Right, delete this, go up. Right, so if it's equal to 0 and the previous is larger than 0 and this is the end. So we delete this one, Once we're done, we check one more time because I goes out, right? And we say if matrix I j is equal to 1, the previous one is equal to 1, then position.add new int. So we have a new thing. Position.add new int I minus 1 1. So go up, we go here, this is should be minus 1. Okay, that shall be right. Oh shoot, that's not right. M. This is also M. Okay. All right, so I think I can change these. Delete this. On this. This. Wait, hold a second. Oh, it's not the same. Okay, and then we'll delete this one as well. Right. Okay, so we do this. All right, so after that, we will have an array of positions. So collections dot sort, or I think maybe we can do position dot sort. All right, comparator dot compare int tuple. We'll compare 0. Oh, how do I compare two things? Maybe I don't have to. Maybe by default. Hold on. Maybe we can just use collections. Position. Does it work? It doesn't work. Comparator, I forgot. Java comparator, compare int. Comparator, 2 fields. Compare 2. What's the rule? Give me the rule. What's the rule? Compares 2 arguments. Here we go. First argument is less than, equal to, or greater than. Okay, so we have to pass a compare. So you're telling me that we can do pos.sort, and we say it's gonna be a function, right? So we can say what? Top 1, top 2. Can we do this? It's a JavaScript. If top 1, 0 is, oh, that's not right. 0, no, get down to the right. If this is smaller than top 2, 0, we'll return -1. Right. If top 1, 0 is larger than top 2, 0, in this case we'll return 1. Otherwise, we'll return top 2, 1, 1 minus top 1, 1. This works. Oh, my bad. This is not right. Top 2. Oh, okay. So we shall just say, go up. If top 1, 0 is equal to top 1, no, top 2, 1, 0. right? And then otherwise we'll return top 1 0 minus top 2 0. Go up, delete this thing. Okay, so we sort it, and then we're gonna say res is equal to 0. So we want to find the largest. Then I'm gonna scan it. How do we scan? We go one by one. And if it's a 0, we do. If it's so we need to know the current largest. Yeah, the current largest. But I mean, we're going small to large, so every time we hit it, we can just see its previous, right? The previous will always be the biggest. Okay, so we just say for int I equals 0, I smaller than position dot len. Size. Right, and then we say we also have a current. Go up. Where's up? Up to the end. Int current is equal to 0. Go back. Oh, that's not right. Back. Constant is this. All right. We say if position dot get I 1 is equal to 0, then current plus. Else I don't want this, I want this. So if that's gonna be this way, I might have to get this one as well. No, I did something wrong. Yeah, do this, go down. Okay, so else it's a 0, right? Then we say, what do we say? We say the previous, the largest, and the current. The difference between the two is the length. So the difference between is the length. So it's position dot get I 0 minus position dot get I minus 1. That's always going to be the largest, right? That 0 plus 1, and we do this times current. It's the number of ranges overlapping, so we times that. That's the total. And we go to the front, we say res shall equal to math.max res and this value. Go to the end. Right, res will equal to this. And current minus. And at the end we return res. Okay. Alright, is this one right? It's correct. Let's try it. Got it wrong. That's okay. Let's take a look. Expected 34. Oh my god. Page down. We have to go for 24. That's alright. Let's do this. Matrix. So it's gonna be this, right? All right, so we're gonna go for this. Vi this. Delete it. Come down. Find this. Pay. Oh, that's not what I want. Again. Paste. No, we pasted the wrong position. Well, I still don't understand. So paste is after. Gotcha. So again. So I delete this. Come down. We go to the end. Back. Paste. Okay, go down. Delete this. And. So this is gonna be largest, whatever. This is gonna be matrix. All right, let's run it. Yep, it's wrong. Okay. Let's draw this. Oh, that's a lot. How many? 1, 2, 3, 4, 5, 6, 7. Hold on, but alright, the first is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 18. So at least I have 18 at the beginning. Oh, this is hard to debug. It's okay. Let's go back. Just what do you want? I want page up. Let's debug. Where do we put? Let's put it here. Let's see the position. I do only have 23 though. So 0 to 23. Oh, did you do a last one? What do you mean? I think it's the last one. Yeah. So another one, math.makeMax res. The position is going to be position.get position.size. Well, it depends. Depends the last one, right? So I think it has to be undo if the last position, so position.get size -1, if the last one is, because the last one is a 1, we're already ending it. If the last one is a 0, right? 1, if that is a 0, right? We're gonna do res. Nope. Let's just go www all the way to size. Not size, not size, not size. -1. 1. No, 0. Right, that's the leftmost. Minus, that would be the end. What's the end? The end will be back. Is going to be m. Should be m-1, right? Minus this plus 1, so it's just m. So we do that. Rest, oh no, times current. Then we return. Alright, is this one right? No, it's still 24. Or it doesn't matter? Yeah, I mean, should it? It doesn't matter, because at the end it's just the end point. Yeah, I think, hold on. No, this doesn't matter. What I say is, if it's a 0, it's a start, right? And then at the end, it's gonna, at the last one, we might have 0, 0, 0, 0, 0, 0. So we'll have everybody's start. But oh yeah, they will always end. No, I don't think that's the problem. It's still gonna be wrong. I think you put it right. You put it wrong. Minus this rest. Let's go to m. Should do this. Is this right? Yeah, it's another problem. Hold on, it's fine. Let's think again. I have 26. So 0 start we have all the way to 20, so 24. And then we have the ends. Right, we have ends. So be all the 1 0. So we have a bunch of 1 0s. That's fine. So it'll be 24, 20, 24, 23, 22, 21, 1, 2, 3, 4, 5, 6, 7. I have 7. 1, 2, 3, 4, 5, 6, 7. Yeah, I have 7. Right? I have 7. So 24 minus 7 is 17. 18, 19. Huh? That's interesting. Should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17. Yeah, 17 should be get a 2. Oh yeah, so the first round, oh here is 17, right? Minus this, so these something and then I hit 17. Right, so we have a start from 0, 0, 0, and then 1, 0, 1, 0. 1, 2, 3, 4, 5, 6, 7, 8. 17, 18, 19. Then I hit a 1. Huh? That doesn't make any sense. When we hit this, it's 24. 20, right? And when we hit here, 1, 2, 3, 4, 5, 6, 7, 17. And we hit a 0 again. Right? We hit a 0 again. We have something that's starting from 1. That's not right, starting from 1. I think maybe this one is wrong. Hold on, so if it's equal to 1, start a new stretch. So like this should be 0, 0, 0, 1. That's it. This should be 0, 1, and 1, 0. It's also 0, 1, 1, 0. Yeah, we have a bunch of 1, 0s. No, we shouldn't have a 1, 0. There's no 1, 0. Nothing start. We have 1, 0. We only have 2 1, 0s. Ugh. Wait, hold on. I'm confused. I think I'm confusing myself. We have bunch of, so we have a 0, 0. We have bunch is starting from 0, 0. Right, a bunch of is starting from 0, 0. And then we'll end at 0, 1. 0, 1, we have a bunch of 0, 1. Then we have a bunch of 1, 0. Actually, not bunch. I think only have 2 start 1, 0. And then we have a bunch of 1, 1. Right? So it's basically start from 0 to 1. 0 to 1. A bunch of this. Okay, we'll have a couple 0 to 0. So when we handle this, we have 17 left. Right, we have 17 left. And we handle some 1, 0s. Right, so we should still have 17. Yes, I still have 17. Look at this. Right, we have here is 17. 18, 19. Right? And then boom, boom. Oh, I see. You should kick back to the previous. Oh my god. Ah. I know it's yeah. This part is wrong. You shouldn't get to the previous one. Right. So we go da 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 da. So the. Oh gosh. How should we do this? Start, right? Start. So start from a certain one. We have a certain number of counts. So when this count is done, We can use a stack. We can use a stack for this, or we can use a map. Because I need to know when the previous one is done, right? So when I hit a 1, right? I hit a 1. What I want to know, what is the biggest so far? And once I use it, I can pop it, right? If I know the biggest so far, and when I use it, I pop it. Okay, the next one, I pop it. The next one, I pop it. So I can pop all the way to the end. Oh, what do you think about using another list? I don't know. I mean, can we not use a list? No, we have to use something. We have to use something. But we can use a stack. Okay. Pre. Okay, so which means every time I do this, stack pre dot push I. Right? That's the, we push the I, because this, bless you. We push, and every time we hit this, what we need to do is, this is the current minus, that's wrong, this is wrong. This is wrong. It shall be position.get pre.pop 0. And then do this. I don't think we need to do this. Let's run this. Yep. I think this might be the one. All right, come on. Okay. Oh, that's wrong again. Output 57. Jeez. Hold on, need to feed the cat. You got stuck.
Aye.
What happened?
They hit my knee.
Oh, yeah, guys. I think I know why it's wrong. No. So we increase, right, all the range, overlap, and then we hit something. Right, we hit something, and then that means at that position we end the current range, whatever the range it is, which means so far right? So far, shall be good. What I have so far, all the way up to this point. So how many range is overlapping? How many range is overlapping? So we have 2 range overlapping. Then I say times 2. That's 3 range overlapping. Then I times 3. Now we have that much overlapping. Yeah, we have that much overlapping.
It's all about me.
All right, I'm back. Let's take a look. We have that much overlapping. This overlapping, next one. Right, so when we hit here, yeah, we get the current at the front of the stack. Right, we get this. If we have a bunch of this, when we hit this, we get this with the current, and now -1, this one's gone. Now when you hit this, we pop this. Okay, I don't know why this is not working, but we can.
It's all about me.
Oh! Press the wrong button. I just quit everything. Hope it's still going. Oh yeah, it's still going. I accidentally turned it off. I got the wrong answer. Okay, let's do this. Here. No, that's not gonna work. Okay, what if we delete this? Oh, that's not gonna work. Ah. Nope. Nope. No, 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 no. Let's take the first 10. I hope it's wrong, so I have an easier test case. Nice, it's wrong. Okay, so this is easier to do. This is much, much easier to do. Okay, let's do this. So 0, 1, 2, 0, 2, 0, 2, 1, 2, 1, 1, 0, 2, 1, 2, 0, 0, 2 2, another 0 2, another 2 2, another 0 1. Right? 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5 6 7 8. That's 11. What's the last 0 1? 0 2 0 2 1 2 1 1. Good. 0 2 1 2 0 0. Oh, we have a 0 0 2 2. That's fine. 0 2 2 2 1. Okay, so we sort them. Right. So we have 0 0 0 0. Actually, we don't have to sort. For this, we can just go through. So we have 0 2 times 1 2 3 4. 1 2 3 4. So we have a 0 0. I have a 0 1. Now we have 1 1. 1 2 times 2. 2 2 times 2. Okay. Alright, so what we're gonna go through is we have 4. 5. 5. Sorry, 5. 5. Nah, it's okay. Alright, so we have 4. So 0 0 0 0 4. 5. So we have 0. 6. So I have 6. And then first, so 6 is the first answer. 6 is first answer. Now I have 5. Right? Now to 1. 0 to 1. Right? So current is 1. So 0 to 1. Length is 1. I have 5 of them. Yeah, 0 0 0 0 0 to 1. No, length is 2. Because it's plus 1. Alright, it's plus 1. So it's 2. 2 times 5 is 10. Now I have 10. But then we had a 1, so now it becomes 4 again. Okay, 4. But we hit a 1, 5. So this is 5 because it's a 1. That's a 5. Hit again, become 4. Okay. Now we hit 2. Now we have 6. Right? 4, 5, 6. 7, 8. We have 8. Okay. Now we have 8. Because from 1 to 2. Right? From 1 we hit 2, 1. Awesome. Now we have 8. Now we hit the first one. That's 2 2. Right? So we push a 2 in, so that will be 8. Right? Now we have 7. That's a 7. Now we have 6. Right? Then we should put, it should be 1. So it should be 12. Right? Now we have 5. It should be 10. That's it. So it should be 12. Answer is 12. Answer is 12. I think it's the coding issue. I think it's the coding issue. Alright. I think we confirmed. I think this is a coding issue. Hate it. Absolutely hate it. Coding issue is always, very disheartening because that's like, why would you having coding issue on this one? That's not right. No. debug. Hold on. Oh yeah, be with us. Thank you. All right, let's debug this. Let's see. 1, 2, 3, 4, 5, 6, 7. Let's put us without drawing. Five, 6, 7. Yeah. And we hit 3 1 zeros. Yeah. Oh, we hit 3 1 zeros. Oh, that's the issue. 3 1 zeros. I shall hit this 1 1 first. Oh, the sort. The sort. So it shall be 1 first? Yeah, that's the issue. Like we hit a 0, we hit these one first. But these shouldn't be hit first. Because this is the end. This is the start. This is a start. This is a start, this is the end, right? So if we start and then we end at the same spot and have something else start. So when it's the same, end shall go before start. So I shall say minus this and plus this. So yeah, if the position is the same, we shall do it the reverse style. What's wrong? Huh? Empty stack exception. Oh. Then these will go first. Oh my goodness. Hold on, let me think. Yeah, we have 0 1. The 0 1 will goes before 0 0. Oof. I think to avoid this from happening, maybe we should go +1. You know, maybe we should go just +1. So instead of 0 to 2, okay, so when we start, yeah, this is the started position, start, right? And then if we end and the start happen at the same time, if we end and the start happen at the same time, then I want this to end first, because this is already end. So what we want is prevent how do we do this? How do we do this? Okay, I don't want to use, like, say, another data structure just for this, because I think it should be sufficient. Yeah, even with this, let's say it's 0, 0, how much is that? Right? If 0, 0 gets encountered first, but it's not encountered first because this one we encountered the last, which means everybody will encounter, so the 1, 1 is the same. Oh yeah, hold a second. I don't think it's... Really, should we encounter this one? Because I start at 1. And these starts at 1 as well. Oh, 4, 5, 6. Then I hit this, so that's first the 6. Right, then I hit this. Then I should also hit this. This is a 1, 1. This is a 1, 0. 1, 0 go before 1, 1. That's the problem. 1, 0 go before 1, 1. It's not this problem. It's this and this the problem. So we have the starting position 1. And then we have an end position at 1. So I say, because it's like this, right? We have 0 to 1, and we have 1 to something. So when this happens, you encounter this, and then you encounter this. Which one gets counted first? If you count this one first, then you count this, right? Because this is basically, I say, I 0, 1, and then we have a 1 as a start. So if it's the start, I can count this. But if it's the end, I can count this. So it depends on when you end and when you start. Right? So if I start, I say it's gonna be 0, let's say a negative value. And then we hit 1, that's the end, and we put the starting value here. So I know this is the start. So this is going to give me 1 minus something will go first. And then I hit this. Yeah, I hit this. Which one should I go? Which one should I go for? Right, I have 0, 2, 4 of them. 0, 0, 0, 1, 1, 1, 1, 2. 2 of them. 2, 2. Right? So you say we count 0, the start, count 0, the start, count 0. So I have 6, cancel 0, 1, so we have 5. Oh, if I have 6, cancel, now we have 5. Just wait, 4 of this plus 1 of this. Right? And I hit this. That's why I say I have 10. But instead of hitting this first, I hit this first. Right? Now I have 6, 7, I have 7. Then I hit this. Now these two shall only go to, because it's a start. It doesn't even count. Then we'll find the end. Find the end position. So this end position, what's the previous for the end position? Actually, the end position is these two, because I pushed this, I pushed this. So the end position for this is actually these two. Huh. 4, 5, 6, 7, 8. So this is actually giving me 8. Which it could be 10. Let's give you 8. Yeah, this is not right. When you end at a position, check your previous. Yeah, because I know this is the point where we end. But I want to know where is the closest start for this position. The closest start is this. It's a lot of things wrong. When we hit this, right, we're ending it. Yeah, so when we draw a line here, we're ending at this, and we're starting at this. But you say start goes first. That's fine, but for the ending, so you say end shall go first. Doesn't make any sense. Maybe we should sort this way. What if we sort it this way? You know, with a start. What if we sort this way? It'll be 0, 0. Right? And then 0, 1. 0, 2 times 4. 1, 1. 1, 2 times 2. And 2, 2 times 2. And then I'll expand for each one. Then I'll expand. How do you expand? Either 0, 0 start, 0 end. That's not right because you have all the other zeros. They all count. Yeah, they all count, man. They all count. Or like for this ending, right? For this ending, what for each ending, what is the current starting position? What is the current shortest starting position? And if you think about it, we have two choices for this. That's the thing. There are two choices for this one. For this, I can either belong to this part, right? So it's like this. So I have some 0 to 2, 0, 1, yeah. I have 0, 1, 2, and I have 4 of them. Okay, I have 4 of them. And now we have this 0 to 0 handled. Now we have the 0 to 1. Right, now we have 1 to 2. 2 of them. And then 2 to 2. 2 of them. Right? So the biggest shall be here. 1, 2, 3, 4, 5, 6. Right? These. Yeah. I don't know how I got 15. That's even more wrong. But anyway. But now the question is, we are looking at... So we're supposed to get to this one. And I add all these. So for this, if I count all these, that's only 1, 2, 3, 4, 5, 6, 7. There's only 7. We'll count that 7. Alright, that's not right. For this, I have two options. I can go here. Alright, but if we count a star first, so we count these. Right. Now for this, I have this, or I have the previous one. Maybe. So I go this. Now it kind of depends on when you call this one, when you call it. Yeah, this algorithm is not right. Push, 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 push. And now pop. And then now push, push, pop. Push, push, pop. To this, pop. To this, pop. This, pop. This, pop. Let's debug again. All right. Okay, so 2, 3, 4. Should be 5. Right. 2, 3, 4, 5, 6, and one more. Okay, so now the first position is 6. Okay, so this is first 0, 1 comes up. So we go here, right? 0, 1 comes up. So we pop previous 0. So it'll be 1. So that's the 6. Rest is 6. And then current minus minus. Now we get 5. Current is 5. Now it's 7. 1, 0. We have a 1, 0. Yeah. Another 1, 0. 8. Another 1, 0. We have another 1, 0. Okay, so now we had to hit a 10. That's the individual 1. Alright, it's the individual 1. I didn't even draw it here. This is individual 1 because it started with 1 and a 1. Or it could be any one of them. Right? It could be, no, we have 2, 2, 1, 1. Right? 1 is the individual, and the other is that. So for the first one, it's going to be the current pre. think I pushed this wrong. I shouldn't push I. That's not I. This should be... Yeah, this is wrong. This should be position.get I 0. $24. It's even more wrong, but oh no, it is right. No, it is right. It is right. It is push I because I will pop it and position get this. Find it's 0. Ah, Lord, I have to redo everything. I think all the way down to 0 to 10. Okay, now it's 11. Yeah, but it's hard for me to check. No, it's hard for me to check. So, although it's the same thing, but I think it's easier for me to do position.get I 0. Okay, and then we'll change this. Free.pop. Yep. So I have 8. Okay. We still add 9. Let's still add. So I has 10. Okay, I has 10. The first 1 1. So first 1 1. We're gonna pop. That's a 1. Right? So we are 10. The rest is 8. Oh, because current is 8. Right? 1, 2, 3, 4, 5, 6, 5, 6, 7, 8. Yes, it's an 8. Now current is 7. Right, now current is 7. We are at 11. Which is another 1 1. Is this one, right? Yeah, this will have an issue because it's basically this one. We have current is 7. Current is 7. How'd you figure current is 7? Oh, we have 4, 5. 4, 5, 6, 7. Yeah, 1, 2, 3, 4, 5, 6, 7. Right? But for this one, I should, because for this position, its smallest can extend way back, and I say it's 1 because of these two, the starting position. Right? Basically, I hit this one first, but this one shall go first. So it's the ordering issue. It's the ordering issue. The starting position. The starting position. The starting position. What are you saying? That for the end, right? For the end, when you're ending, two arrays. One is the starting position, the other is the ending position. So the ending position will be sorted. Yeah, because this 1, 1, right? This 1 shall come out earlier than these. That's not true. That's not true. Because if this is smaller, then this one will be longer. Right? Yeah, it's true. So okay, so to change the mindset. So whenever we're gonna pop, whenever one range ends, we have multiple choices, right? That's correct. We have multiple choices ahead of us and to the left. So we can choose the current or choose the previous. Yes, basically I have 1, or I can do 0. I can do both, right? I can do 1, I have so many. If I have 0, I have so many, right? If I have 1, basically I have 1, 2, 3, 4, 5, 6, 7. I have 7, right? I can do 7 for this. And but that actually I can choose this. This can it? I cannot. This one is be ending at here. So ending at this position, this is the only one ending at this position. So you should have a choice. Choice, right? I have a choice. But then we have to loop back on this. How many different ones do we have? And for this, ending at 1, this, and it just, there's more computation, right? There's more computation for this. And if you imagine, we have a lot more singles going. Yeah, there's a lot more singles going. No. Yeah, we should always prioritize going to the left, right? Because if we have a bunch of this going, then some one of this will definitely hit it. Or if I have a bunch of this going, right? Should be ending at this position. Ending, yes, ending at any position. If we end at this, what is the largest possible? If I end at a position, what is the largest possible, right? And if we sort based on the starting position, okay? And if the start is the same, I go the earliest end. So if I sort them this way, and then I'll go, right? And then we say ending at this, right? Ending at this. But I already started. Troubling. I already start. This is the start. This is the end. So if the start of an end is earlier than this one shall have precedence. But how do I code this? How do I code this? We start and end, right? So for the starting thing, I sort them there. This one goes first. So ending at this, what is the most? Man, I got stuck. I just keep going. So this will do 8. Okay, next I is 12. Should I come to this one now? Current is what? 6. 1, 2, 3, 4, 5, 6. So for this, the maximum I got is 8. So 1, 2, 3, 4. 1, 2, 3, 4, 7. Where did the 8th one come from? Right, we have this. 4. This is gone. 5. 6, 7, 8. Yeah. Then go 2 is 6. Okay. 1, 2, 3, 4, 6. I forgot there's one more. Okay. So now we have this. We have 2 more. We add 2 more. Okay. We add 2 more. All right. So current is 8, and then we're gonna look at number 14. Okay. So be 8, right? Now current is 7. Be 7. Now current is 6. Current is 6. Pre as 1. Current is 6. Oh, I is 16. So that's gonna give us to 12. Yeah, that's goes up to 12. So I think it's this one. And then next. Oh, I get to 0 already. What? That's the problem. We get to 0 already. 16 still 2, 1. 2, Yeah, that's right. We should have 2 starting at 1. And 2 starting at 2. Hold on. Let me just do it one more time. Okay, I is 12. See, that's the problem. I don't have 1. I is 12. I should have 2 starting at 1. But I have 2 ending at. We have 3 starting at 1. Yes, we have 3 start at 1. Three start at 1. 2 end at 1. Oh, one of them end at 1 is not supposed to pop the 1. You're supposed to pop the 0. I don't know, man. This is it used to work. So when you pop, right? When you pop, that's when we got it wrong. It's not this. It's when you pop. So when this pop, I shall remove a 0, which means we need a counter. Right? We need a counter. And every time we gonna pop, we will do 2 things. Okay? So first of all, we're gonna do the current biggest start. We'll keep track of the current biggest start. How do we keep track of the current biggest start? Well, if we have a sorted map, we can keep track of the current biggest start. So we have a current biggest start. Or not. If I have a current biggest start, I can use it. So I get 1 value, or I go to pop mine. Still don't feel right. I still don't feel right. So what I have is at each position, how many we have. Right? That's what I have. At each position, how many we have. And at this position, I have that many. Right? And then we go to the next position, I have that many. That's why it works if we only say at a specific time, at a specific position, what is the maximum number, right? That's what we can do. That's what we can do. Now what we cannot do is extend backwards. And now this one requires to extend backwards. And now we have trouble. Should we get out of this mentality? Yeah, I felt maybe we should get out of this mentality. Let's trigger the hint. Greedy. For each column, find the number of consecutive ones ending at each position. For each row, so for each column, find the number of consecutive ones ending at each position. For each row, sort the cumulative ones in non-decreasing order and fit the largest. What do you mean? All right. Number of consecutive ones ending. No, that should be 0. Number of consecutive ones ending. And sort each row. Sort the cumulative ones in non-decreasing order and fit the largest submatrix. Huh? What? What the hell? I don't understand. Sort each row. What do you mean by sort each row? But this does tell you that we have, so each value tells you how many I have along this column, right? So it does provide more information for this specific position. We know, yeah, so this is 0, we have no, this have 1, right? So we want to put them together, right? Which means at we want to put them together, right? We want to put these together. So after rearrange, there will be we can say for a certain role, okay, for a certain role, because for certain columns they're going to be consecutives, right? Let's say the one with the longest, so you have the longest or the biggest value, so that one can always move to the rightmost, right? And that one always move to the rightmost, okay? And if that one moves to the rightmost, and then for this row, let's say if we can form a submatrix, right? If we can form a submatrix, which means within the submatrix, everybody is 1, right? Within submatrix, everybody is 1, which means in the bigger theme of thing, we can always put this to the last one, and it might have more ones, some zeros, right? We can always, like, it could be the same. So this will definitely be the largest value. This will be the max value if we do the consecutive sum, prefix sum. This will be the second largest. This will be the third largest, or it's be the same. Which means for each row, you sort it, and then go this, right? And you see how many you can lay out. That's the maximum possibility. And then you go from top to bottom, because every row will be the same, right? Every row. So every row, if you trying to get the best, because it doesn't matter, right? So for each row, you can always and if a row, and after you sort, because we hold on, what we want to find is a submatrix, right? The largest submatrix. So for the largest submatrix that exists, that means for one row we'll have, however many we have a value, right? How many ones in this, all the way before we hit 0. So we have that. Each row we have that, okay? Each row we have that, and then we can count. We have, how many ones after we sort consecutively from right to left. So we can go higher, lower, higher, lower, higher, lower. But then how do you make sure that because if in this case, right, that's sort, this one we can sort will be 0 to 3, right? Which means starting from here we have 1, this row we have 3, this row we have 2, How do you know it's a 2? And how do you know it's not a 1? Well, we do know if it's a 1, so we can always say we are going from here, we look upwards. So if there's 2, because it's, you know, consecutive, right? Consecutive sum. So consecutive sum. Yeah, what if this is 0? What if this is 0? No. What if this is 1? This is 0. Right? So we're talking about like this. Should be 3. How we make this work? This will be 1. We sorted, this will be 2. This will also be 2. Yeah. What are you gonna do? Fit the largest. What do you mean? Fit the largest. It doesn't make any sense. I don't know. I'm gonna give up. But it's too long, so I'm gonna end right here, and then yeah, you can just check the solution. Oh, it's simple. No sort. Rearranging the columns have no effect on height. how much height each column contributes on its own. So this will tell you how much height each column contributes. So the height is 3. How much height each column can contribute to a given row? We sort in descent. At column 0, we have seen 3 consecutive ones. At column 1, we have seen 2. 2, we have seen 0. Yes. Two, 3. So what you're saying is at each row, we rearrange, we sorted it. So if we consider a row is the bottom, and because sorted it, we say the height, then we can say this height times this, height times this, height. Ah, I think I got it. So this is the same. This will be sorted. Yeah. So when we sorted it, or some value, some value, some value. This is the width. This is the height. This is the width. This is the height. I see. Alright, let's code it up and then just call it a day. Yeah, failed this one. But the idea was wrong. Trying to use this method, it doesn't work. J. Right, let's just delete everything. Okay, we'll redo this. We need consecutive ones. Nah, why do you redo everything? We don't redo everything. We don't need this. We need this. We need this. Yeah, I just change. It's okay. So if it's equal to 1, start. Count equal to 1. End of the current stretch. Not really. Not really. You know what? I want to redo this for. Alright, so we shall say if it's equal to 1 and the previous is not a 1. So if matrix I j is equal to 1, and alright, we'll also have here if I is larger than 0, and this, and I minus 1 j is equal to 1. So current is a 1, previous is larger or equal to 1, previous is larger or equal to 1. In this case, say matrix I j shall equal to matrix I plus 1. Okay. And at the end, if no, it doesn't matter. I don't need this. Now we can delete them and delete this. Okay. So with that, now we can go through every row sorted. Okay. So we say for int I equal to 0, I plus plus. Arrays, I'll sort matrix I. Okay. Then, we shall reverse sort it. Otherwise, yeah, reverse sort will be much easier. I cannot do that. Ooh. I guess it's all right. I just sort and then go from right to left. Yeah, it's okay. N minus 1. And matrix I matrix ij is larger than 0, j minus minus, Right, so for that, in each one, we shall say res shall equal to math to maximum res matrix I j times n minus j. Right? ij is height, n minus j is the width. So we do this and go up. Delete this. Delete this. Enhanced for. Return res 12. Fail. Unable to solve this one. Okay, the solution is smart. We compute the height of each height of ones at each cell, then sort each row then we know for that row, right, for that row what is the max height for what is the height of a submatrix, what is height for any, what is the max possible height for max possible height for each submatrix, max possible height for each submatrix of a given width. Ins j is the max height of ones at position j. N minus j is the max width to accommodate the height ins j. OMN log n. So we have to sort. All right, that'll be it. It's like 2.5 hours.